All right, so here we go with Chapter 8 Notes, Part 3. This is covers Section 8.5, which is using intercept form. So far we've talked about two different forms of quadratic functions. We've talked about standard form, we've talked about vertex form, and now we're going to talk about intercept form. Okay, and there's a reason why we call all of those different forms those specific names. And so standard form is called standard form because the equation of the parabola is in standard form. You started with the highest exponent and then you went down. Okay? And then in vertex form, last time we talked about how this is called vertex form because it tells us the vertex. Okay? And so now we've got what's called intercept form. Okay? And before we talk about why it's called that, let's just go ahead and graph it. And the reason I've put this hint here where it says you can put the equation in the calculator just as it is written is because a lot of times you guys see this and you think, oh, well, we could FOIL. And you could, okay? If you FOILed, you get x squared, and then 6x plus 2x is 8x, and then 2 times 6 is 12. So if you were to plug both of those into your graphing calculator, you would get the same parabola, okay? But you don't even have to do that. You don't even have to do that work. You can just go in and plug in x plus 2 times x plus 6, just like that. And then if you hit the graph button, okay, it'll graph your parabola. Okay, so let's go ahead and graph it as normal. So we go to our table. It looks like the first one we can graph is -7, 5. And then -6, 0. -5, -3. -4, -4. -3, -3. -2, 0. -1, 5, and we've got an extra box here, so why not do 0, 12, okay? And then we go to our graph, just like we always have. So we go -7 up 5, -6, 0, -5, -3, -4, -4, -3, -3, -2, 0, -1 up 5, and then 0, 12. And then we connect our dots. Okay? Oh, that's terrible. You get the point, though. There we go. It doesn't actually dip quite that low. There we go. That's a little better. Okay, anyway. Okay, so let's go ahead and fill in this box before we talk about why this is called intercept form. So hopefully you see by now this has a minimum, okay? That minimum is at -4, -4, okay? The axis of symmetry is going to go right down the middle here, okay? And that's at the point x equals -4, all right? Still all the same things that we've been talking about since day 1, but anyway. The domain is all real numbers. The range is y is greater than or equal to the y value of your minimum, so that's -4. And the x-intercepts here are -6, 0, and -2, 0. Okay, and I'm going to pause here. We're going to talk about increasing and decreasing as well, but I want to pause here. Okay, this is why we call it intercept form. Notice that the x-intercepts here, okay, are -6 and -2. And if you go back up here to this equation, you notice that 6 and 2 appear in the equation. And kind of like how we talked about with transformations, when a number is paired with x, it's a bit counterintuitive. You think like an x plus 2 should move it to the right 2, but it in fact moved it to the left 2. And so when you look at this, you can see, okay, well then our x-intercepts moved to the left 2 and to the left 6, which is what happened here. So this is why we call it intercept form, because when an equation is in factored form, it gives us the intercepts, okay? So intercept form in general is x minus p times x minus q. Sorry, you can't see that. X minus p times x minus q, where p and q are the x-intercepts. And so what you're basically going to do is look at, well, what are the numbers here and here, and then change the sign. Okay, so as a different example, if you had x minus 3 and then x minus 1, the x-intercepts would be 3 and 1. And the cool thing about this is if you didn't know that, let's say you completely forgot that, you could still go to the graphing calculator and see it. Okay, so you don't have to have this stuff memorized necessarily. You just kind of have to be able to reason your way through it. All right, let's go ahead just because we've been talking about it. And let's talk about where this function is increasing and where it is decreasing, because I'm still going to be asking for those things. And so we always start with x and x. And the number we're going to be comparing it to here is this -4. And so then we just have to decide where it's increasing. So we go to our vertex here and we look to the right where x is bigger than that -4 and we're increasing. So that means we're decreasing on the other side. Okay? Nothing crazy here. It's just a different form. Okay, so those are the 3 forms we're going to talk about. We're not going to talk about any more. Really, there's not any more. Standard form, vertex form, and now intercept form. Okay? So come with your questions ready, and we'll do some practice in class tomorrow.